In this video, I will show you how to make a matrix for a vertex edge graph, and I will show you how to make a vertex edge graph like this one from scratch. So, look at the vertices that we have. We should put them in alphabetical order if we want to make a matrix. Let's have some order out of the chaos. So, JKLM. Okay, we'll put them across the top and down the sides. JKLM. So, each entry represents the number of connections between the vertices. So, for example, between J and L, you can see that there are two connections. Okay, that's why between J and L, there will be a 2. And there will be a mirror image of that here between L and J. It's a two-way street. Two connections between L and J, or J and L. Okay, now, a vertex cannot have a connection with itself, so these entries along the diagonal will all be 0, because this would represent a connection between vertex K and vertex K, L to L, M to M. No such thing. Okay, is there a connection between J and K? Yes, there are 2 of them. Kabam, which means K and J. Same thing. Is there a connection between J and M? Yes, there's one connection from J to M. So I'll put a 1 there. That means M to J, same thing. Alright, how about K and L? Oh, there are no connections between K and L, so that's going to be a 0 here and here. LK, KL, same thing. What about K and M? Sure, there's a 1 connection between K and M, which means M and K, same thing. What about L to M? Yes, there's 1 connection between L and M. M and L. So this matrix represents this vertex edge graph. Okay, let's do one more problem. Create a vertex edge graph for the following situation. Then create a matrix to represent it. So we're talking about transportation. An airline serves 5 cities: Lowell, Montana, Newman, Peoria, and Orlando. Did I say Montana? Montour. Okay. LMNOP. Alright, so I know the matrix is coming, so I'm going to go ahead and letter these now in alphabetical order, please. LMNOP. Alright, so the problem says that there are flights between Lowell and Montour. Okay, so there are flights between Lowell and Montour, so there's going to be a 1 there. You know what, I guess I should set up my little vertices here as well. So here I go. L, M, N, O, P. So, you know what, I'll put the dots like this. Using my vertices. So there are flights between L and M. Okay, so I've recorded that on my picture and in my matrix, which it should appear twice. I might as well put these zeros down the diagonal, because you can't have a flight from one city to itself. You just stay in the airport. So let's keep going. Between Lowell and Orlando. Okay, so Lowell and Orlando. So there's Lowell and Orlando, Orlando, Lowell. Montour and Orlando. So there's Montour and Orlando. Okay, Montour, Orlando, Montour, Orlando. Newman and Orlando. Okay, Newman, Orlando, Newman, Orlando, Newman, Orlando. And Newman and Peoria. So Newman and Peoria. Okay, so Newman and Peoria, Newman and Peoria. So everywhere else should be zeros on my matrix. You know what, it's sort of bothering me that the lines are crossing over the other lines. It makes it unnecessarily confusing. So I think I'm going to move this over here somewhere. Alright, I think that looks a little better. Alright, well, there you go. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.